Screen is visible to all? Yes?
Yes, sir.
Yeah. Here the question is given the three phase. With three phase. Everyone please note it down because I may ask questions in middle. So a three phase 400 volt 4 wire system has a star connected load with ZA, ZB, ZC are the impedance. They are given as ZA equals to 10 plus I0 ohm plus I0 ohm. ZB is given as 15 plus J10 ohm, 15 plus J10 or I10 ohm, I10 ohm, and ZC is given as 0 plus J ohm, 0 plus J ohm or I5 ohm. Okay. Now find the line currents. Find the line currents and current through neutral conductor. Neutral conductor. Okay. This is the question given. In question only, we can say that this is the unbalanced 4 wire star connected load. Okay. Here, see, three phase and neutral conductor, that is 4 wire system. It means this is unbalanced 4 wire star connected load. This is unbalanced 4 wire star connected load. Okay. Now, yeah, first one, we need to find the line currents and the current through neutral conductor. Current through neutral conductor is given as, I'll give the formula here, IN equals to IA, IB, IC. Here, ZA, ZB, ZC are nothing but these are given the phase sequence A, B, C, like R by B. Here, IN equal to IR, IY, IB, like that. Okay. Now, for star connection, the line voltage leads phase voltage by 30 degree. We know that for star connection, for star connection, line voltage, that is VL, leads phi phase by 30 degree. Okay. Now let's take phase voltage VN, phase voltage VIN be the reference. Then I can write phi phase equal to VL by what? Phi phase equal to VL by, for star connection, I already told whatever the voltage given in numerical questions, that is a line voltage. So I can write V line divided by root 3. Now how much? 400 divided by root 3 is yes 400 divided by root 3. How much?
230.1, sir.
230.94
230.94.
volts. I reckon 231 volts. Okay. Now I said phi phase lags by 30 degree. Okay. And phi an is the reference. Now phi an is equals to 230.94. Reference in the sense angle what I don't mention here 0 degree. Phi an equals to 230.94 0 degree volts. Okay. Then next phase sequence, that is VBN. Then phase, these are nothing but the phase voltage is VAN, voltage across the winding. This is N, this is A, this voltage VAN like that. Okay. Now second one 230.94, then angle up if
minus
A
120.
phase yes sequence minus 120 degree. Okay, then 230.94 and angle of minus
120.
240 degree or plus 120 degree. Okay. Now, please, anyone of you having the calculator in the sense, please tell me, convert that 10 plus 5 ohm to polar form. See here it's given 10 plus I. Convert this to polar and tell me 10 plus J or I equals to
Sir, 10 angle 0 degree ohms.
oh yes. Next ZB 15 plus I10.
Sir, 18.03 angle is 33.69.
33.69. Yes. Next ZC, that is 0 plus I5.
5 angle 90
5 and angle up plus 90 degree ohm.
ohms.
Yes. ZA, ZB, ZC we have converted into polar form. Okay, now phase correction. Why? Because we know the formula I equal to V by Z. Okay, and the calculation will be simpler if we convert those rectangular to polar. Now you need to calculate IA. 1 minute. You need to calculate IA, that is VAN divided by ZA. IB, that is VBN divided by ZB. Then IC, that is VCN divided by ZC. Okay, we know here 230.94 and angle of 0 degree divided by 10 angle of 0 degree. Okay, then 230.94 angle of minus 120
Minus
degree divided by 18.03,
18.
yeah, 33.69. Then IC is same, plus 120 or minus 240 degree divided by 5 and angle of 90 degree. Tell me the values for this. IA, IB, IC.
Sir, 23.94, 23.094 angle is 0 degrees.
23.094 and angle of 0. Yes.
12.81.
12.81.
Angle is minus 153.69 degrees.
153.69 degrees. Next.
46.2.
46.2.
Angle is minus 330 degrees.
Minus 330 degree. Okay, minus 330 degree. Here you can see IA, IB, IC. These are the line currents. Okay, see. If this is my circuit, we have calculated IA, IC, IB. These are the line currents. Now we need to calculate IN. This is neutral. This is in question neutral conductor. This is the neutral conductor with zero impedance. Then I can write IN equals to IA, IB, IC. Okay. Now these are in polar form. If I convert this polar to rectangular, I'll get 23.094 IA, 23.094 angle of 0 degree. Sorry. Plus I0. Then IB 12.81 angle of minus 153.69. I'll get 11.483 minus of I 5.7. Okay. 45.2 and angle of minus 330 degree or plus 30 degree. I'll get plus 40 plus I 23.09. Final, my neutral current, the current through the neutral conductor will be 51.61 plus I 17.41 ampere. Okay. Here the conversion you must know. Rectangular polar to rectangular, and formula whatever. If this neutral conductor having the impedance Z equals to 0 means 0 impedance, then I can write neutral current equals to sum of all the line currents. IN equals to IA plus IB plus IC. Okay. Now we'll see another problem with neutral impedance. Okay. Here that is neutral wire with impedance Zn. Okay. A question is given as the three-phase. Change color. Wait. Okay. A three-phase a three-phase 4-wire 400-volt supply is connected to an unbalanced load. See, this problem I am solving from Bakshi. Okay. So after This is three-phase unbalanced chapter. You list out some problems which are unsolved. Again and again I am repeating this question. List out some problems which you are not understanding. Give it to me, I will solve in the class. Okay. Now, coming to this problem, a three-phase 400 volt supply is connected to an unbalanced load with the impedance ZR, ZY, ZB. Okay. Here in the last problem, ZA, ZB, ZC. Okay. The notation is different, but the phase sequence is ABC, RYB. Okay. With impedance ZR equals to 0.4, sorry, 10 an angle. Consider this one as angle here now. 10 an angle of 0 degree. Next, ZY 8 minus J6. ZY is equals to 8 minus of J6. All are in ohms. Okay. Ohms. 8 minus J6 ohms. And ZB is given as 5 and angle of 0. 5 angle of 0 degree ohms. Now, the neutral impedance is given as Zn equals to 0.4 plus J1 ohm. Now, find the phase voltage and phase current. Find the phase voltage and phase currents. In star connected, phase voltage and phase currents, how they are related to line voltage and line currents? Anyone quickly tell me how they are related? Phase voltage and line voltage, phase current and line current. Yes.
V phase is equal to VL by root 3.
Yes. Line voltage by root 3. Phase currents.
Line current by root 3.
How?
Both are equal.
Both are same. In star connected,
Oh,
phase
yes,
current
star-
equal to line
star.
currents. Okay. Now, I already told 400 is my phase voltage or line voltage. This is
Line voltage.
Line
Yes.
voltage.
Phi L equals to 400 volt. Then phi phase equal to 400 by root 3. How much I will get? 230.94 volt.
09.
Yeah.
No,
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 0.94. Okay. Now, if my phase sequence is R, Y, B, I'm going to take R as a reference. Okay. Phi R as a reference. Or I can simply write, see here, phi Rn, phi Yn, phi Bn, or simply I can write phi R, phi Y, phi B. If I'm going to take this phi R as a reference, then we know 230.94 and angle of 0, then minus 120, just only we are saying, right? Minus 120, then plus 120 or minus 240. This is VR, Vy, Vb. Okay, ZR is given as 10 angle of 0 ohm. Okay, here whenever we are solving the problem with neutral wire with impedance Zn, we need to convert that ZR, Zy, Zb to YR, Yy and Yb. If Zn is given. Okay, if not given, Zn equal to 0 means neutral conductor impedance will be 0. Then In equal to IR plus Iy plus Ib. Here Zn is given as 0.4 plus J1 ohm. So we need to convert ZR, Zy, Zb to YR, Yy, Yb. So now first ZR equals to 10 and angle of 0 degree. 10 angle of 0 degree. Yr is nothing but 1 by, sorry, Yr is given as 1 by ZR. Tell me Yr value, then Yy,
0.1 angle 0 degrees.
yes, 0.1 and angle of 0 degree.
Ohms. No,
Ohms.
ohm inverse.
Ohm inverse, what we'll call it on?
Mho or Siemens.
Yeah. Okay. Now, then Yy.
1 by
See,
Zy.
Zy is given as 8.J6 ohm. Then Yy equals to 1 by Zy, that is, I'll get as 0.1 and angle of 36.86 mho. Here, if I convert this one to 1 plus J 36.86, if I convert this into rectangular, 0.08 plus J 0.06 mho. Okay. Now, which one? ZB. ZB is given as 5 and angle of 0 degree ohm. YB equal to 1 by ZB. I'll get
0.2 angle 0 degrees.
0.2 angle of 0 degree move. If I convert that one to rectangular, 0.2 plus J 0 move. Okay, then convert this Zn to Yn. Zn is given as 0.4 plus J1. Then Yn equal to 1 by Zn. I'll get 0.92 angle of -68 plus 19 more. In a rectangular point, 0.345 minus J 0.862 more. Now we need to add all YR, YY, YB and YN, because to calculate VNO, that is the phase difference between the neutral point of the star connected 4-wire unbalanced load to the neutral point of the supply, that is, see here, you may get confused in this problem if this is given for the external one. Here, after calculating YR, YB, YY, YB, I need to add all YR plus YY plus YB plus YN. Okay, for time being, I'm going to simply write the final answer here like 0.725 minus J 0.802 mho. I'm going to convert this into polar form because It will be easy in means we are going to divide this one with ER into YR. So 38 and angle of is 1.7 more. This is my total admittance of this 4-wire system, 3-phase 4-wire system. Okay, now I need to calculate phi NO. We know that phi NO is given by VR plus YR plus VY plus YY, then VB, then divided by this is Millman's VR, YY, YB, YN. Okay, phi N0, N is the neutral of the load, O is the neutral of the supply. Okay, after getting this first class of 3-phase unbalanced load, you can go and refer those formulas in the video. Here phi NO we need to calculate, then phi R equals to VR minus phi NO.
VON. VR minus VON.
VR minus VON. VR minus VON. Then phi Y equal to, see, capital V. Whatever this V we are calculated, phase voltage, that is small v. Or you can change this one as ER, EY, EB. That is, this is E line, E phase, like that. Okay, ER, EY, VON, then VON, VON. These are nothing but the phase voltages. Then phase currents. Here in star connected, phase currents equal to line currents. Phase currents equal to line current. So IR equal to IR equals to this VR into this YR. Where is that YR? This YR. This YR. Then same IY equal to VY into this YY. Then IB equals to VB into this YB. Just go through these formulas. Okay. Now I'll stop here.